Welcome to the fourth session of Principles of Industrial Engineering. So today we'll be talking about the plant layout. Plant layouts. 5 types of plant layouts are there, like process, product, combination, cellular, fixed layout. So we will be discussing on the questions of this topic. So let's start with the questions. Good evening. Welcome to the fourth live session of Principles of Industrial Engineering. So let's begin the session. So today we'll be discussing some theory concepts and numericals on line balancing and flow cost approach, flow matrix, proximity chart. These are topics which will be covered. So let's start with the session. So the first question is, similar types of machines are placed together in which of the layouts? Okay, the options are product layout, process layout, fixed position layout, all of the above. So as we know that we have already discussed about all of this. In the process layout, the machines and facilities are arranged according to the type of operations they do. The machines performing the similar type of operations are grouped together. In the product layout, the facilities are arranged specifically according to the sequence in which operations are to be performed for the product to be manufactured. In the fixed layout, we have seen that the whatever facilities, manpower which needs to be used for manufacturing the big items like ship or any other big equipments. So the uh, minor equipments, facilities, and the manpower are brought to that location and work is done to get the desired product. So when similar type of machines as already described, these are placed together in the process layout. The correct option is process layout. Machines and facilities are arranged according to the type of operations. Are grouped. Product layout is facilities are arranged specifically the sequence in which operations are to be performed for the product to be manufactured. Moving to the next question. In a product layout, machines are arranged according to the type of operation to be performed, according to the variation in the product part features, according to the worker capabilities to perform a task, according to the sequence of operation to be performed on a job. So, as discussed just now, the product layout, the facilities are arranged according to the sequence in which operations are to be performed for the product to be manufactured. The correct option is according to the sequence of operation to be performed on a job. Moving to the next question. Three important factors need to be considered in a flow cost model are. So, first is we'll understand what is a flow cost approach. The flow cost approach is here what kind of cost that will be occurring on account of handling of the movement, material or movement of the operator, distance to be traveled, whether it is less or more, and cost per unit distance. It is load into distance into cost. So, basing on all these factors, we have the correct option is frequency, distance, and total cost of the movement. Option B. So, I'll just elaborately write about this flow cost approach. First parameter is what kind of cost that will be occurring that will be occurring on account of handling of the movement. Movement, material or movement of the operator. parameter is the distance to be traveled, whether it is less or more. And the third is cost per unit distance. Load into distance into cost. Moving on to the next question. The total amount of flow between the work centers is the only main concern in which of these models? Flow matrix, proximity chart, flow cost model, material management. So flow matrix, it helps us in identifying the work centers where flow matrix, it helps us in identifying the work centers where the movement is maximum so that they can be brought close to each other. So here distance is not the criteria. Also cost is not the criteria. Only the extent of movement is being considered to bring the two work centers close to each other. So uh, this gives us idea about the extent of movement in terms of the number. Like suppose if we take an example of two stations A and B, so we can know the frequency of movement, whether it is 20, 30, 60, 90. So that will be indicating the extent of movement which exists. And if the movement between two centers is very high, irrespective of the distance, then efforts are made to put them closer to each other. So in this approach, we do not consider the distance to be traveled. Primarily, only the frequency of the movement is considered. So, and we see a possibility if they can be brought together. Now, we'll also look into what is a proximity chart. Uh, we will go to this proximity chart in the next question. Currently, I'll just highlight the flow matrix. Helps in helps in identifying centers where the movement is maximum so that they can be brought close to each other. Now, uh, if we compare with this flow cost approach, in the flow cost approach, we consider the kind of the cost that will be occurring on account of handling or movement, handling of the material or movement of the operator. So for this, what we consider basically is the kind of load, which is basically in terms of the number of movements occurred and then kind of the distance to be traveled. So here, so this is here like we consider the load, distance and frequency, everything. But in flow matrix, we only consider the frequency of movements. Okay. So moving on to the next question. A line assembly is said to be balanced when the waiting time for service at each station is same, the equal number of operations at each workstation, the equal number of machines at each workstation, or operation time at each workstation is the same. The correct option is the operation time at each workstation is the same. So, before this, we will understand what is a line assembly basically. So in a line assembly, jobs are assigned to the different stations in such a way that they almost take equal time to complete the job so that efficiency of the line can be improved. Now, uh, now here equipments are arranged in the sequence of the operations to be done. And these are designed in such a way that the activities to each station is assigned in such a way that they almost take equal time to complete, so that wastage of time at each station is minimized. And there is no backtracking and always there is a streamlined movement. This is the characteristics of a line assembly. And in this way it is balanced. So here jobs are assigned to different stations in such a way that they almost equal way, equal time to complete the
that efficiency of the line can be improved. So moving to the next question. Multi-story building is preferred over single-story building if in which of these cases? So in case of multi-story building, this basically for certain manufacturing conditions it doesn't suit. Like except when the product to be manufactured is very small, light in weight, then this kind of buildings can be used. Okay, so otherwise these type of the buildings are best suited for like hotels, schools, shopping malls, etc. These are not preferred for, usually not preferred for manufacturing plants. uh, but in some conditions when the land cost is very high and the multi uh, story buildings will be able to manufacture good enough to manufacture the light and small size components, so they're specifically preferred in those conditions. And uh, s- uh, uh, the biggest factor is very heavy machinery is required for manufacturing, cannot be are usually not, they don't prefer a multi-story building as it is not feasible for the smooth functioning of the plant. So the correct option is for the manufacturing of uh, pie, plant causes high, light size products and not very heavy machinery required. These are some of the points where multi-story buildings are preferred. Okay, so moving on to the next question. Preferred layout of an automobile industry to manufacture the vehicles is, well, the correct option is product layout, and this is because we need uh, the job according to the sequence of operation. According to the sequence of operation to be performed on a job. Next question. For the large overhead space requirement, the preferred type of building is multi-story building, special type of building, highway building, all of the above. So, in case of multi-story building, as we know, this does not suit for the manufacturing conditions except for the criteria measure explained before, like the product should be light in weight, very heavy machinery should not be required, and when the land cost is very high. So only in those conditions we usually prefer the multi-story building. Then again we have this special purpose building. These are considered to be inflexible as they're designed to serve a particular kind of purpose, and once these are not in use, then their obsolescence possibilities are very high. So such examples of such kind of buildings is like the buildings which is designed to accommodate the aircraft. In aircraft industry, they are having very wide expanse, so they can accommodate the aircraft. And like some are having just the ceiling, the roof to accommodate the machine, and the sides in when there is no wall. So these are the special cases as far as building design is concerned. In the case of high bay building, it is a single story structure, but very long roof is available. Like we can give an example of approximately 10 to 12 meters, uh, and it provides a very uh, high overhead space for the use of facilities like such as cranes, overhead facilities. It also provides very good condition and natural lighting. So when the heavy structures need to be moved or used in the building, a lot of overhead space is needed for the efficient material handling. So in such cases, the high bay buildings are found to be useful. A very long roof is available. Good ventilation and natural lighting. Is needed for efficient material handling. Okay, so moving to the next question. Production time per unit product for manufacturing. A product is generally maximum in which type of layer? Well, as we already discussed in our first question, since product layout is based upon the sequence of operations to be followed, so it is very streamlined. So the time per unit product for manufacturing product is very less as compared to the process layout, where we already saw that in process layout, where we already saw the this is not according to the sequence of operations. Rather, The machines are and facilities are arranged according to the type of operations they do. Like the machines performing the similar type of operations are grouped together. Machines Moving to the next question. Now we have come to the numerical part. So here we'll be discussing on line balancing. So line balancing, it consists of an assembly line where the number of activities are in sequence. Like a single let's assembly line, it is an equipment which involves a task. Okay, so I'll just explain a little bit about line balancing. This consists of work element or activity or task, and we have a precedence relationship. Okay. So our objective is we are sometimes given the cycle time and we need to find the minimum number of workstation required, and sometimes we are given the number of workstation and we need to find out the cycle time. So here these are the basic form workstation. Now we'll understand what is a workstation. Workstation workstation, it is the location in the assembly where group of tasks or work elements are performed. A cycle time, it is the time between two consecutive outputs from the assembly line. Now minimum cycle time is decided by slowest workstation. Location in the assembly assembly line where group of tasks or work elements are performed. Now, next is cycle time, total workstation, works. Now, line efficiency, this is very important. Line efficiency is equal to total work contained by number of workstation into cycle time. Total work contained by n into cycle time. So we will give the abbreviation for this. This is TWC by n into T subscript C. This is the cycle time. So this always should be as high as possible. Line efficiency should be as high as possible. Now, workstation time. Now, total work contained, it is sum of all the activity time or task time in an assembly line. Okay, and balance delay. Again, one more thing will come. Now, for this question, we have been given A, B, C, D, E, F, G. These are the workstations which have the following times in an assembly line, and we need to find out the line efficiency of the assembly line. So, according to this question, the total work contained by cycle time is cycle time. We have to see that it is the minimum cycle time is decided by the slowest workstation. Okay, and how it is with that is that it should be maximum than the tax the which is the highest. This is the highest task time, so we 10 is the highest task time, so we assume 10 is the highest task time, so this is the minimum cycle time. Minimum cycle time is always greater than the maximum uh, task time. So for this question, efficiency is equal to excuse me. Now we'll solve this numerical. Now, as we know, line efficiency is equal to TWC by N into TC. Total work contained. Total work contained is equal to 9 plus 8 plus 6 plus 10 plus 7 plus 7 plus 9 is equal to 56. Minimum cycle time or we can say the slowest workstation. Slowest workstation is which takes the maximum time, that is 10. Then n number of elements is equal to 7. So line efficiency becomes, according to the formula, 56 by 7 into 10. This is 0.8, which when we convert it to efficiency, it becomes 80%. Okay, so the correct answer is 80%. So moving on to the next question. The table gives here details of an assembly line, and it is asking what is the line efficiency of the assembly line. So again here we will calculate the total work contained, which is 7 plus 9 plus 7 plus 10 plus 9 plus 6. This becomes 48. Now number of elements is equal to 6, number of stations, and your cycle time, which is the maximum time taken or slowest workstation, which is 10. Now line efficiency is equal to TWC by N into TC is equal to 48 by 6 into 10. This becomes 0.8 is equal to 80%. So your correct answer is 80%. Moving to the next question. So in an assembly line for assembling toys, 5 workers are assigned tasks which takes time of 10, 8, 6, 9 and 10 minutes respectively. The balance delay for the line is. Now in this question we are not asked about the line efficiency but the balance delay. And as I already explained, balance delay is balance delay is equal to 1 minus line efficiency. Now, uh, the, so this represents the ineffectiveness of the assembly line. Hence, it should be always as small as possible. So, we'll again calculate here the line efficiency. So, line efficiency is equal to TWC by N into TC. Now here cycle time is again 10 and number of workstations are 5 and total work contained is 10 plus 8 plus 6 plus 9 plus 10 by 5 into 10, this becomes 40, 43. By 10 into 5, this becomes 0.86 is equal to 86%. Now balance 14% is the correct answer. So, moving on to the next question. An electric equipment manufacturer has decided to add a component subassembly operation that can produce 80 units during a regular 8-hour shift. This operation consists of three activities as follows: mechanical assembly, electrical wiring, test. For line assembling, the number of workstations required for the activities M, E, and T would respectively, which is the assembly. So here we are asked to draw to find out the assembly, like which will be the sequence of operations. So here first we will find out the number of units produced in a day is equal to 80 units. Now working hours in a day is equal to 8 hours. Now time taken to produce 1 unit is equal to T is equal to 8 by 80 into 60 is equal to 6 minutes. Okay. Now we will find out the number of workstations. This for M is equal to 12 by 6. This will be 2. For E will be 16 by 6 is equal to 2.66 or 3. You can round it up. This is 16. T for workstation T, it will be 3 by 6 is equal to 0.5. We will again round out the highest near to the integer, it is point, which is 1. So number of workstations are the whole numbers, not the fractions. Okay. Here, so the order is sequence. Number of workstations are 2, 3, 1. 2, 3, 1. So the correct option is option A. Moving on to the next question. Now, here we have to draw, we are given the cycle time, we have to design an assembly line for the following set of elements, and we are here given the element, time and precedence. Okay, so it's just, we have to follow the procedure. There is nothing difficult in this, like now let's take the first element. One, this is the first element. Now 1 is the first element, so it has no precedence. Okay, next is 2 is preceded by 1, 3 is preceded by 1, and 4 is preceded by 1. So they will have this will be the order, and the arrow mark will be towards this. Okay, so next is 2, 3, 4, we are done. Now the element 5 is preceded by 2 and element 6 is preceded by 4. Okay, so element 5, element 6, and now element 7 is preceded by 3, 5 and 6. So we will have, this is the element 7. Okay. Now element 8, 9 and 10, 3 are preceded by 7. 8, 9 and 10. Next, element 11 is preceded by 8. Element 12 is preceded by 5. And element 13 is preceded by 10. Sorry, element, yes. So it's correct. Element, oh, I just got confused with the time. This is the time. Element 11 is preceded by 8. 12 is preceded by 10, and 11, 13 is preceded by 9, 11, 12. So element 13, let's make the element 13. Now first element 11 is preceded by 8. Element 12 is preceded by 10, and element 13 is preceded by 9, 11, and 12. So this is your assembly line for the following set of elements. Now we have to balance the line and determine the following: balance delay and line efficiency. So you will put all the time in this chart and you will find out the line efficiency by efficiency is equal to total work contained by n into cycle time. Just add up all this time, put the number of elements and put the cycle time and find it. Balance delay is 1 minus line efficiency. So moving on to the next question. The only criteria considered in the flow matrix chart is. So we already discussed about what is a flow matrix chart. Flow matrix chart is where we consider the frequency of movements. Now, total flow distance, total flow direction, these are not, and total flow time, these are not required. The only thing which is required here is total amount or frequency. So, flow matrix will help us in identifying flow matrix helps us in identifying work centers where movement is maximum, so that they can be brought close to each other. Cost, distance, direction, time, these are not considered, so that they can be brought close to each other. Moving to the next question. Diagram or chart used for line balancing a product layout is which of the following? Precedence diagram, Simo chart, string diagram, or proximity chart? precedence diagram, it represents the sequence of the elements. The correct option is precedence diagram. This represents the sequence of elements with the word content. It shows the kind of activities that are completed first before taking up the next activity. Now, proximity chart, we already discussed, it is the graphical method for the relationship between two workstations. Correct option is precedence diagram. Moving to the next question. Flow matrix basically focuses on this. We have discussed numerous times. That is, it returns a number of movements. It gives us the idea about the extent of movement which exists in terms of number, like frequency of movement between the two stations. Suppose if we say it is 80 or 90 or 70, so it will be depicting the highest number of movement exists within which workstation, and if the when it is too high, irrespective of the distance, efforts are made to put them close to each other. So in this approach, we do not consider distance to be traveled primarily, and only the frequency of the movement is considered for seeing the possibility whether they can be brought closer to each other. Moving on to the next question. The characteristic features of plant layout of a high bay building are single-story structure with a higher roof, multi-story structure with a higher roof, maximum overhead space with natural ventilation, or less overhead space with natural ventilation. The correct option is option 1 and 3. That is single-story structure with a higher roof and maximum overhead space with natural ventilation. So in case of high bay building, it is a single-story structure. Very long roof is available, say more than 10 meters, and the maximum 10 meters, so it provides maximum overhead space, and for use of cranes, overhead facilities, it provides very good ventilation and natural lighting. So when the heavy structures need to be moved or used in the building, a lot of overhead space is needed for efficient material handling, and in these conditions the high bay buildings are found to be useful. Okay. So moving on to the next question. By using gravity flow method, the material handling cost is lowest in which of these types? Single story, multi-story, or high bay buildings, or all of these. So there are various levels, various floors are different levels. So if possible, we can use the movement of material under the gravity conditions, like shoots and all those things can be used for the movement of raw material or semi-finished products or finished products from one level to another. So this in turn can help to reduce the material handling cost. So multi-story building designs can offer the advantage of the gravity, that is the use of the gravity for material handling purpose. But apart from these benefits, there are few undesirable and negative features related with multi-story building. These are like difficult to design the flow of material. That is, sometimes the material handling is also difficult in case of multi-story buildings. Further, very high uh, uh, the space wastage for auxiliary units such as elevators, floors, uh, staircase, service facilities, a lot of space is wasted, and also we have the less load bearing capacity. Like in multi-story building, we have only one foundation. Then the different floors will be housing the different machines, and these floors are not considered to be as strong as the ground floor. Only we can accommodate the heavy machines with regard to the load bearing capacity. So the ground floor will be offering much better load bearing capacity as compared to the floors at the higher level. That is why the floor load bearing capacity and the construction cost is also very high. The last question is graphical method for relationship between two workstations is related to this we already discussed. It is the proximity chart. In proximity chart, it is the graphical method between two workstations. Again, previously we had already discussed the Gantt chart, flow cost method, and flow matrix. So with this, we end today's session. Um, Thank you all for attending the session. Let's meet again next time.